Then I'll bring the new chip over, place it down on the board, and heat it all up until the solder melts and connect the joints between the board and the chip. So I'm going to come in and flux it up. Flux doesn't do a ton in this scenario because the hot air is going to kind of burn it off before it gets hot enough to lift. But I still like to use it because I feel like it probably does still help some amount. So I'm going to start with my hot air wand a little bit higher off the board. This heats a larger area. And then as I go, I'm going to lower the wand a little bit further and a little bit further until it's right over the chip and the heat is concentrated right where I need it. So it's almost ready to lift, but not quite. These boards take a ton of heat to really do anything, so almost there. You can see the solder getting shiny. There's a large plane, ground plane underneath this chip, so it takes a lot to heat to remove. Okay, we got to be getting close. Oh, still not. Come on. Almost there. I keep thinking it's almost there. There we go. Old chip removed. I'm going to heat this back up while I have the new chip ready. And I'll bring the new chip on. Get it close. And then move it around with our tweezers. Come on. Okay, that is pretty close. Now I'm going to use some flux all the way around the chip. This is going to help that solder flow a little bit better. And then I'm going to come in and reheat it all again. My hope here is that all the joints will connect. And also that large ground plane on the bottom will also connect. Okay, we'll bump it a little bit. Yep, all melted. Okay, job done. I do need to clean it still though. Now while all of the flux is warm, it's a great time to come in with your cotton bud and just soak a bunch of it up. Leaves less cleaning to do. Everything's cool. Okay, now let's have a look at these solder joints. Make sure they're all connected. That side looks great. That side also looks great. How about this side? And that side looks great. So we've got our retimer chip replaced. Let's get this thing back together and see if that fixes it. Okay, I've got it cobbled together enough to test. Let's power it on. We get a white light. That's good. Anything on the screen though? And we're getting nothing on the screen. Okay, so the retimer didn't seem to be the issue. I'm going to replace the booster next. If that still doesn't fix it, we'll dig into it deeper and start doing some diagnosing and see what's going on. So boosters and retimers are both super common items that go bad on these. So I'm just going to replace the booster next. So here is the booster chip that we looked at earlier. I've already got it fluxed up. So I'm going to come through with my hot air wand, heat this up, remove it. Then I'll use some solder wick to wick up any of the excess solder. Then I'll place the new chip, heat it up until all the solder balls underneath melt, and then let it solidify, and then we'll test it again. So again, I'm starting up a little bit higher, and then as I go, I'm gonna lower it until it's right over that little chip. And I'm watching all the little components around it to watch for the solder get shiny. That'll kind of give me a hint as to when the solder and the chip should be melted. And I am seeing some of those components with some shiny solder, so we'll give this chip a bump. Nope, nothing yet. Now I'll come in a little closer now that the whole board, or this portion of the board, is kind of preheated. Come in a little bit closer and get some of the resin heat right over that chip. Alright, now we can see the chip kind of moving with the hot air. Rebend it here. Alright. Now I'll just heat up the wick while I put it over the pads. And then just kind of glide it around. And there we go. Okay, all of that solder has been removed, and add a little bit of flux. There we go. Then I will place the new chip. Once your tweezers get some flux on them, they get pretty sticky. And the placement isn't going to be exact. Okay, that's going to be close. Now I'm going to come in with my hot air again and heat up that whole area. And then as the solder balls on the chip melt, the chip will slide right into place. Whoop. I'm going to kind of hold it in place with my tweezers a little bit. There we go. Now just directing heat kind of straight down onto the board. And once that solder melts, the chip should snap right into place. That's the hope. It is a little bit crooked right now. Oh, that might have been it. It looks a lot straighter, but I need to heat it more and make sure everything is nice and hot. Okay, it looks like the chip is moving around. So let's give it a little bit of a bump. Yep, there we go. Okay, that is right in place and perfectly straight. Now we'll let everything cool down and give it a test. Okay. So it's back together enough to test yet again. It's turned on with the white light, and again, no signal. So we've already replaced the two most common things that cause this problem, so now we've got to figure out what else might be going on. So what I want to do next is use an HDMI tester to test this HDMI port and see if it's getting all of these lights to light up. That'll tell us if the circuitry and port are good. So I'm going to plug this back into power. We'll turn it on. Okay, it's on. We get the white light. Now let's see what happens when we oh, we get nothing at all. Wow. Nothing lights up. We don't even get the 5 volts to the port. Okay. What if, let's leave this and wiggle the port, cable. There's nothing at all. Okay, so let's see if we get 5 volts on the board. If we can actually, I'm not sure we can really get down to it and test it with all these boards together. Okay, so that's definitely a problem. The other problem is we don't get the chime when it starts up. So I'm actually going to put in another one of these top boards right here and see if that top board will chime. Okay, the old board. And the replacement. I don't know 100% for sure, but I think it is. Okay, so power supply back on, and we'll see if this board will make a chime. Alright, now we'll plug in the power. There we go. And here we go, power button. Oh, I didn't hear a chime. When I was testing this beforehand, it did chime, and now it's not chiming at all. Okay. Still nothing on the HDMI tester either. So what I want to do next is check pin 18 and see if it is showing 5 volts. That'll tell us if the HDMI port itself is good. I think it probably is, but okay, that is showing 0 volts. Yep, and we've got 0 volts. That 5 volts, I believe, is generated by that small BGA chip we replaced. And maybe the redriver too. It might go through the redriver. I'm not totally sure on that. Either way, I replaced both of those chips twice with chips that I know are good. So I'm getting a little worried about this board. Whatever is turning those chips on or telling them to send 5 volts to the HDMI port is probably just not working. So we're getting no voltage at all on the HDMI port. We've replaced this twice, both known good. I've rechecked all of the solder joints around here. I've rechecked all of these components and there's no shorts. The booster on the other side of the board we've replaced twice, one with a brand new one with a known good one, and it is still not giving 5 volts to the HDMI port. So I think at this point there's something much deeper going on this board, and unfortunately I don't think it's something I can fix. So here's the other problem with these boards is this board is married to this board. They used to not be like that on the Series X, but these newer versions are married. So for whatever reason, the sound isn't working on this board. It did chime when I installed the other top board. It obviously didn't in the video, but it did before I filmed the video. So there's also something going on here, and I feel like it may be related to the South Bridge. I don't know for sure, but I feel like it probably is. So I can't just replace this board with a different one either. And given that this board has the unresolved HDMI issue, we'll just replace both of these boards. Now, I've never replaced the sound chip and the speaker on the Series X. I did one on an Xbox One X and it worked fine, but I don't know if it's going to work on this one. So let's get that done and hopefully it's going to work for us. So this is the board that has the custom chime and sound. And this is the speaker that goes with that board. And this, I believe, is the chip that runs that speaker and makes the sounds. So this is the board on just an original Xbox that doesn't have any customized sounds. So I believe this is the chime chip or the chime speaker because this one doesn't have that speaker instead. So I think what we need to do is remove this one, install the speaker onto here and the chip onto here, and then you should be good to go. There also is, let's see, we've got a couple little components over here that we need to replace as well. So I think what I'll do first is get all of these components placed over the board, and then we'll remove this chime. So I kind of wonder what would happen if we left it to see if it would chime and make the custom noise. I also don't want to burn anything out or cause any problems, so I don't know if I should do that or not. But let's start by getting the speaker off, or trying to. I think what I'll do is heat from this side of the board and melt this solder on the 4 corners, and it should allow us to pull this speaker up, but it looks like there is some adhesive on it, so that could be difficult. We also need to make sure not to mess the speaker up because this is the only one of these I have, so hopefully it will go okay. So I'm going to use my hot coiling device and the board up. That should work. And now we'll get it heated and see if we can get the speaker off. These boards take a ton of heat, so I don't know, we'll see. Also, this is the kind of thing that you're interested in learning how to do, especially if you have no experience. I've got courses that will teach you everything you need to know, from someone with zero experience to someone who has a decent amount of experience. I've got a beginner course that's totally free, and then 2 other courses, an intermediate course and an advanced course. Everything from beginning soldering to soldering with a hot air station. That's over at GameConsoleRepairSchool.com, so be sure to check it out if you're interested in learning how to do this better. Alright, and now we will start heating the board. Just going to be kind of going in circles right on this part of the board. See if we can get this speaker to loosen up. Unfortunately, the speaker does look like it's made of plastic. Usually the plastic they use doesn't melt easily, so I think we'll be okay, but it always does make me a little nervous. Okay. Oh, and I'm using a temperature of 1100 degrees Fahrenheit and an airspeed of 3. Now, your airspeed and temperature may need to be different. You'll be soldering in a different environment than I'm in. So, your settings probably need to be different than mine. I also don't like heating these speakers up just because there's a lot of plastic parts inside of them, so that also makes me a little nervous. So, did we break anything or melt anything we shouldn't have? That's the next question. Decent on the outside anyway. Before the pad. So, let's get those off. That's not a big deal. A little bit of flux on there. Go. There we go. Okay. I think the speaker came off decently. Definitely can't tell for sure, but I think it's going to be okay. So next, we need to swap parts. So I'm going to be swapping a bunch of parts from here over to there. And we're going to start with this resistor right here. There we go. Have some flux. Make sure that is on there. Got some good solder connection there. There we go. Alright. Next, we got 2 capacitors over here. One. Super tiny. tiny one over here. Okay, we're good there. Now a little bit bigger one. The bigger one seems so easy after dealing with those tiny ones. Add some fluff, and the fluff is just helping it flow into the places. There we go. Okay. I think that's basically everything. Now we're going to go for the chip. A lot of heat on this chip.
Well, guys, don't forget to like, share, and subscribe. Alright, guys. Big up, big up. We're doing Chan Mission on a Pathfinder. We just take down the subframe. Thank you for stopping by. Hope to consider subscribing. Look, this.
Now we'll add a bunch.
So we're gonna be changing the Chan Mission on this car. So thank you. Don't forget to subscribe. I'm gonna be going back onto the car. You wanna say hi?
There we go. Okay, that chip looks really good. So next, we need to remove this guy. And since I don't care about it, not more if I need them, doing work, whatever, but I just want to get it removed. So I'm going to heat these up. Prefer not do any damage on the board. Oh, there we go. Okay, that was easy. Okay, that one's removed. Now we need to install the speaker onto here. So what I'm going to do is fluff these up nicely. There we go. Line it up correctly. Fluff here, and the fluff is there. I marked that out before. That looks pretty good. So I'm going to put a bunch of solder on the iron, and first package is done. Yep, it's good we checked. We got a little bridge right there. So let's get that fixed. First, let's flux it up. Then we'll turn our fume extractor on. And we'll bring our iron in and just touch that up. Ooh, come on, there we go. Looks like all those pins are connected. I'm going to run my iron over them just to make sure. Yep, we're good. Okay. Good there. I'm just checking these pins to make sure that they're all connected. And they definitely are. Okay. Alright, looks good. Do a bit of cleanup real quick. Also, those capacitors are good, that resistor is good, and those capacitors are also good. I'm going to touch this little guy up just to make sure. Yep, good to go. Okay. And now with that done, we can get this back together enough to test and see if we fixed it. Just when I thought I was done, there's more on the bottom. So we got to place all of these components on the bottom of this board. So let's get that done, and then we'll finally be able to test it. Okay, this first one is one of the smallest components we have here to replace. And that's going to go. Almost had it. There we go. I'm going to add a little bit of flux to that. Reload it again, just to make sure it's right on those tabs. There we go. Alright, now I'm doing the next smallest component. Getting the small ones out of the way first. This one goes right up here. Okay. And some flux and reflow. There we go. Alright. Now we got a little bit bigger guys coming up. These are some pretty good sized capacitors. So they'll be a little easier to do. Yeah. Got a place, so now we'll add flux. And repeat. Alright. 2 more of that size. Here's one. Kind of got it up on its edge a bit there. See if it'll fall down on its own. We might need to push it down. Oh, nope, there we go. Oh, almost. Yeah, we got it. Maybe lunch, my hands are getting a little shaky for this. Ah, lost it. Okay. Ah, come on, so close. Pretty tight height tolerances in between these, so not too surprised there, but there we go. Oh, come on now. You guys don't need to be friends. Woo, there we go. I'm gonna heat those all up one more time. Oops. There we go. Just to make sure they're right where they need to be. Alright, we've got one larger capacitor. This one should be a piece of cake. Should have secured my board a little better. I'm moving around on me. There we go. And now we've got a fuse coming up. Definitely would not have worked without this. And now some flux. Okay. And now we'll slide that fuse over just a bit. There we go. Alright. Now I think we're ready to go. I'm just going to clean this board up a little bit off camera. Then we'll get it installed and see if it'll turn on and make some noise. Alright, we got to plug in. Let's see if we get a custom noise. First, does it make the exact noise? Oh yeah, that's good. Here we go. I think I was talking during it. It definitely did make the noise. Start it up and we just turn it off. Okay, I'm going to press the button to turn it off so you can hear the noise, and I'll actually stop talking this time. There we go. That's what I'm talking about. Now I got to get this put back together the rest of the way and make sure it outputs to HDMI. Make sure everything else works. Now with the core all together, that's not the right way. This is the right way. There we go. There. Looks really good until it doesn't look good, but and now the disk drive. The cover that goes over the disk drive. Alright, now we got to put a bunch of screws in and we can get the back plate on. Alright, and now the back plate finally. I really hope this thing works after all of this work. I feel like I say that during every video, but I mean, it's totally true. Alright, there we go. Get this thing plugged in and see if it's going to work. And all plugged in, let's see if the power button makes that special noise. Totally does. And there we go. This is all fixed up, totally working. I really wish we could have gotten that other motherboard fixed that came out of it, but it's still good to see this one working, even though it's not necessarily the ideal fix. I'm not sure that I'd actually be able to make money on this if I had to go and purchase a separate motherboard, but since I do have them here in the shop, it made it a pretty easy fix. Thanks so much for watching today, and I hope you have a good one. Recently, Austin Evans made a video where he broke some electronics using a USB killer. So I reached out and asked him if he would send them over my way to see if I could fix them. And he said he would. So I have all the boxes. I'm not even sure what all he sent. So let's get him open up and find out. And here it is, box number 1. Okay, looks like a laptop. What is this, a Toughbook? I don't remember if that's what they're called or not, but dead USB kill. So we've got one laptop, and what is in box number 2? A PlayStation 5. So this is the 1100 model, and it does not work. We also have, looks like you threw in an Apple iPhone. All right, we'll have a look at that as well. Let's see what's in the last box. Okay, and we have another laptop, and another laptop. What else do we have in here? Another, oh, is this a tablet? Nope. Oh, here we go. We got MacBook Air, looks like. Okay, so that's going to be a fun one. That's actually in really nice condition, too. All right, and we have a Nintendo Switch Lite. One more laptop, and this is an older MacBook Pro. So we've got our work cut out for us today. I think now is an appropriate time to say, I'm not a laptop technician. I've fixed a few. I've tried to fix a bunch that I couldn't. So I don't know how this is going to go, but let's get started and see if we can fix any of these devices. All right, I'm going to put a thing and we're going to go for it. Simple as that. Super, super duper dumb. So let's start with this Lenovo Chromebook. It's got a USB meter set up. Let's see what happens when you try to charge it. Okay, it just turns off. Let's do that again. Yeah, it just turns off right away. Let's just see what happens when we can plug it in on this side. 5 volts, 0 amps. Yeah, so there's nothing going on over here. Okay, let's get this thing taken apart and see if we can figure out what's going on. So right over here is the charge port. So I need to get this main board out so we can have a look at the other side. And here we are under the microscope. This is a USB port that the USB player is into, and how a USB player takes power from the device and stores it in very small So the first thing we're going to be looking for is any fuses or resistors that might be blown. And I'm just taking a look at the board right now just to see if there's anything that looks obviously blown. This 0 ohm resistor right here could be acting as a fuse. Let's check that real quick. And we get 0.8 ohms, so that is just fine. Well, let's check this resistor. 1.19 kilo ohms, that looks just fine. I'm going to change over to audible mode. So now we're going to hear a beep whenever there is a short to ground. So there is a short to ground on the case of the USB port, which we would expect. Let's check all these lines. Okay, no surprises so far. Unfortunately, without a schematic, there's no way for me to really know whether some of these should be shorted to ground or not. Usually a big coil like this wouldn't be, but it's just really hard to know. Let's check this control power management. Again, I'm just checking to see if there's a bunch of pins shorted out or something. So far, there's definitely not. Doesn't mean it's not bad, but a lot of times when these go bad, there'll be a large amount of those pins shorted out. So given the fact that this chip just doesn't have really any shorts on it, I think what I want to focus on is this area up here. So this coil is shorted to ground on both sides, and these pins are all shorted to ground as well. So is the 0 ohm resistor. That is shorted to ground. So I think what I want to try and do is remove this chip right here. I don't know what all is on this circuit that could be shorted, but this looks like probably the most likely cause. But there's just no way for me to know for sure, especially since I don't have any schematics for this board. So let's try that and just see what happens. There we go. And that short is still there. Yes. There we go. Okay, so I'm going to remove this chip next and see if that does anything. And with that chip removed, let's recheck the shorts. Unfortunately, I don't like, it is possible that this is how these are supposed to be. Everything is the same. This is the downside of not having any schematics to go off of. So let's see what happens when we plug this into a charger with that chip removed. Here we go. Whoa, that is pretty up close. You can say nothing at all happened. All right. So I'm going to put this chip back on, and then actually I'll put both chips back on. Let's see what happens once those chips are back on. And that short is still there. Again, not sure if it's supposed to be or not. But let's see what happens now when we plug our charger in. Just see if that happened to do anything at all. All right, and here we go. And we get the exact same problem. Now, unfortunately, I don't have one of these chips to replace it with. My guess is this chip is probably faulty. I definitely could be wrong, but without a schematic, there's just no way to really test it, and I can't find a data sheet anywhere for this chip. So unfortunately for this Chromebook, I can't say for sure what the problem is. I'm guessing this chip took the brunt of the voltage coming in and probably killed this chip. Now, as you can see, there's a bunch of little lines going to the chip from the USB-C port. If there was some fuses on these lines, that could possibly prevent this problem, but unfortunately, manufacturers kind of cheap out on this kind of stuff and just don't install those fuses. So we're not starting out great, but let's move on to the Gateway laptop and see if we can fix that one.
Let's see that. Because nothing. Now that it is plugged in, I'm going to trigger the control. There it went. Good. Stop it.
So let's just see if it happens to turn on. Definitely no power. Plug it in. Definitely no power. Okay, let's take the button cover off and see what's going on the inside. So that is where the power comes in, right over here. Definitely got some fingerprints over here, so this has been into before. Let's get this board out so we can have a better look at it. Actually, before we do that though, let's disconnecting the battery and then reconnecting it and just see if that does anything. 7.8. Okay, we got a little bit of voltage in there. So disconnect. Let's see what happens if we try to plug the AC adapter in with the battery disconnected. No lights, no anything. Okay. Let's plug the battery back in. Now let's see what happens. I don't think that's going to do anything, but sometimes crazy things happen when you unplug it and plug it back in. Yep, nothing. All right, let's get this board out and have a look at it. So here is the AC in port, and this is the power coming in. So let's check. We've got these two 0 ohm resistors that can act as a fuse. And which is good. And 0 there. I'm testing voltage. I need to be testing resistance. What am I even doing today? Okay, let's try this again. All right, 1 ohm, that's 1. And same there. So those are both good. That means that the inrush of voltage and current didn't blow these resistors. Let's just check we're short on the capacitor. Good there. And let's check these MOSFETs here and see what we have. No shorts on those. Okay. looking around the board to see if there's any actual fuses here. Let's check over by the battery connector. So there's the battery connector, and there's a 000 resistor. That's good. So one more up here. Let's just check it anyway. Yep, that is good. And this one is also good. Let's check this one. No problems there. So I'm just seeing nothing obvious on this board that's blown or burned out. The next thing to do is actually plug in the AC adapter. Let's see where we get voltage. Okay, there we go. Now we'll switch our meter over to DC voltage. And let's see what we get. And we have 19 volts in. So we're good there. Let's check over here. 19 volts there. And I'm just going to do some checking around over here. Those don't have voltage, which isn't necessarily a problem. 18.9. This guy. So no obvious problems there. Let's go over here to near the battery connector. And this guy right here is the charge controller. And we have voltage. I'm just kind of checking this thing for voltage and shorts. Just kind of, I don't know what this should look like when it's working. But if it was shorted, that at all on this chip. It appears just from very rough prodding and poking that this is probably working fine. 20 volts, 24 volts right there. 18 volts. So I think this chip is probably fine as well. Unfortunately, I just can't find anything obvious wrong on this board. None of the fuses or resistors that can act as fuses are blown, so all of that looks just fine. The charge circuit seems just fine. That being said, a proper laptop repair technician might be able to figure this out quickly. I'm just not seeing anything obvious, and I just have no leads as to what might have gone wrong with this board. So in this case, and on the previous laptop, the USB killer is a really covert way to kill a laptop board. Since this is kind of a cheapo laptop anyway, I think we're going to stop here so we can put a little more time into things like the MacBooks. So let's move on to the next laptop. And the next laptop we have is this Dell Latitude Rugged. So let's see how rugged it is on the inside. All right, here we go. Ooh! And that is dead. Okay, definitely no power. Let's get this thing taken apart. This is a lot more intense inside than I was thinking it would be. Okay, so, I mean, we can't really see much yet. I don't see anything crazy going on here yet, but we can't really see the board very well. So I need to get a bunch more of this stuff off, and then we can have a look at the board. So in Austin Evans' video, this is the USB port that he plugged the USB kill into. I'm looking back here, and these two little guys look like maybe there's a problem there. We'll get under a microscope in a second, but that we definitely need to inspect that. Also, I'm seeing a number of places where there are fuses on this board. Anything with these zeros on them either are or can act as fuses. So that's looking promising there. I'm not sure why I didn't turn on though. That's the main thing. Also, in Austin Evans' video, you can hear kind of like 2 clicks or 2 snaps when he plugs that device in. I'm wondering if it's from these guys here, but also where did that send power to make it just kill the whole computer? That's one of the main things that I'm going to be trying to figure out in this video. We have the DC in right here. That's what that connects right here. So we'll check that in a minute too. But right now, let's just kind of look over the board and see if there's anything obvious that looks blown or burned or anything like that, other than those two little guys behind that USB port over there. On this top side, I am not really seeing much. And on the bottom side, a number of fuses as well. We'll check those here in a minute, but just nothing that really looks burned or broken, or even sometimes components will have kind of a little bubble on the top. Nothing like that going on. So let's check all of these fuses and see if we find any that are bad. So we'll start back here. That fuse is good for sure. Good. Okay, no problems so far. So that, I don't see any fuses that are blown, at least not obviously. Okay, let's try the back side. I keep hoping we'll find one of these fuses that's blown, because that would be an easy fix if that's all it was, but man. We're not having any luck so far. Okay. I just don't see anything that fuse that is causing a problem. So let's get on our microscope and have a look at those two components by that USB port and see what they look like close up. And here we are under a microscope, and these little guys are just totally destroyed. These are probably the source of the two sounds that we hear in Austin Evans' video. And this, I mean, it's sort of good news because these blew, but also the computer also blew. So unfortunately, these, or even this fuse, didn't really do its job if the whole computer blew instead of just these guys. Having these two components blown like this should make the computer not turn on. So let's keep looking and see if we can figure out why it's not turning on. Alright, let's plug it into power. Get some noise, that's strange. See what we get on the thermal cam. Right there we have a problem. Maybe we've got 133 degrees. Right by that guy. Okay, let's unplug. We don't want to actually do any damage here. So that was right near this guy right here. I think it might be on the other side though. Right here somewhere. Let's plug it back in. Yep, plug it in. And we've got right there. 127. Okay, so that is the right spot here. That is right in that area. I'm going to mark this with a Sharpie. Right in here. Okay, so the heat is coming from somewhere in this general area. I'm thinking maybe this chip, but I couldn't really pinpoint it to that. According to the thermal cam, it looked more like it was like right in this area. Which doesn't really make a lot of sense because there's not really anything there. So I think our best bet is to remove this guy, and then we'll retest for shorts. And with that component removed, let's see how the heat looks. We get no warm spot in that area. There's just nothing. That chip we took off is from right here. It's right about where the warm spot was. And without that on there, we don't get a warm spot anywhere on the board. So now the problem is that this little guy right here, 4S0101, there is nothing online about this. So I can't find parts, I can't find a schematic, I can't find anything for this. I don't have a donor board that I've found that has this on it, so unfortunately we can't replace this and test it anymore because I can't find one of these. There's a chance that just replacing this could fix it, but also there's a pretty good chance there are other problems on the board. But unfortunately, without one of these to replace it, we just can't go any further on this one. So while this one is potentially fixable, since we can't get parts, there's just nowhere we can go on it. So let's move on to the first Apple computer.
Plug it into our MacBook in 3, 2, 1. Oh, okay, that's very good. Very, very good. So we heard the click, so it discharged. Now, does the system actually work? It does.
So far, we're 0 out of 3. Well, let's open up this MacBook Pro and see if we can fix our first one. And our screws are out. Back cover is off. Let's see if we have any clues on this board. I dug out my old MagSafe cable. Let's plug it in and see what happens. Oh, we get a green light and fan spin? Does this thing have a display? No display. And we get an orange light, so the fan stops. I mean, that's something though. Let's see what happens when we try to power it on. Okay. Nothing when we try to power it on. Power button down. Yep, just nothing. But we do have a little bit of life on this board. So I think it will take this board out and have a look at the other side and just see if there's any burn components, any components that are obviously broken, and then we'll move on from there. Okay, and I unplugged it and then plugged it back in, and this is what we get. Battery's charging, it is low charge, I know that much, but now this thing's working. Trackpad works. I'm gonna let this charge for a little bit and just see if this charge percentage goes up and see if the charging circuit is fully working or not. We do need to have a look at that USB port though and see if we can figure out what's going on there and see if we can figure out what part of it is blown. So let's get under a microscope and do that next. So right down here is the USB port, which attaches to the board right here. And if we look at the board a little further back, we see this guy. Right here, you can see the half of this thing has just totally been blown off. Now there is another USB port over here, and this is the same component, 0502N. And if we look at this component on AliExpress down here, it says diode circuit protection. Now luckily, I do have an old donor board for this laptop, so I pulled that component off of that laptop, and we're going to place it on this one and see if this USB port will start working again. Come on. Almost. There we go. And now we will place the donor component. Now we can start this thing back up and see if the USB port works. And with that replaced, let's first test the USB port that we didn't fix. We didn't try to fix. And we have 5 volts coming out of it, just like that. Now let's test the USB port that we did try to fix. And we have 5 volts. So it looks like Apple may have done something right and put circuit protection right in the USB circuit and probably saved this laptop. And this one is still working just fine, and we're at 22% on the battery, so the battery is also charging. This is an older laptop though, so let's take a look at the newer one and see if they still have that same circuit protection there.
All right, we're gonna plug this into a USB-C port in 3, 2, 1. Unplug it. Very good sign. MacBook is still functioning. Okay. Oh, that's bad. Both USB-C ports are not accepting a charge. So ready, and ooh, that was good. Ooh, no, it's not. So the MagSafe cable thinks that the device is fully charged and good to go, which seems normal. But here's the thing: the system says it is not charging it. But as soon as this runs out of charge, it's dead forever.
Now before we get doing anything too crazy, let's just plug this MacBook Air in and see if it charges. Oh, orange charger. See what happens when we try to turn it on. Definitely nothing so far. Okay, so we get charging, but nothing's going on the computer itself and it's not starting up. Let's get this back cover off and have a look to see what's going on in here. That is so clean looking. Gotta give it to Apple. That's a nice looking inside of a laptop right there. But did they design it so it'll withstand the USB killer? Over here are the USB ports. We got to get under here and have a look at the board. And then we just pry off this whole metal plate right here, just like that. And there we have the logic board. And I think it's time to get under a microscope and have a closer look at it. So the USB-C ports plug in here and here, and right up here is where the MagSafe plugs in. And then over here on the board, we've got a CD3217B13. My understanding is these are the chips that help determine what the input or output is on the USB-C ports, and that's what controls them. So let's start checking around these chips for shorts. I'm going to do these two capacitors right over here. Okay, and no short on that one. Next we'll go up to this chip and do the same thing. Oh, there we go. That is definitely a short. Let's check this other one. And no short on this one. So this area right here seems to be a problem. I think most likely this chip is faulty, but unfortunately there's not really a good way to tell. I'm guessing what probably happened is all the voltage came in through the USB kill and killed this chip, and that is why this chip is shorted, or one of these components around it is shorted. Unfortunately on this board there is no circuit protection, so it's not just a matter of replacing one of these little chips. It's this fairly large BGA chip that I think probably needs to be replaced. I've looked around this board quite a bit and I don't see anything else that looks like any sort of problem at all. There are no burned or blackened chips anywhere. So I think my diagnosis on this one is that most likely this chip is faulty. Unfortunately, I don't have any of those chips, and I could take this chip off to see if that short goes away. But I don't know if Austin Evans wants this board back or this MacBook Air back, so I don't want to remove this chip because it is a BGA chip, so once I remove it, I can't just put it right back on. So unfortunately, since there is no circuit protection on this logic board, we're not going to be able to fix this one. But let's move on to one more Apple device, an Apple iPhone.
3, 2, 1. Ooh! Ooh! I heard a click and it didn't do anything. I'll unplug it right now. Whoa! Oh, well, hang on. Wait, that's good. That's what happened with the Z Flip. It triggered and is restarting. This looks fine. Let's just make sure that it still accepts power. Oh, wow. Okay. So what we have here is a still functional device, but a lightning port which no longer works.
While we're letting our blue heat mat heat up, let's see if we get any voltage going into the charge port when we plug it in. And we get nothing. Alright, let's get this phone opened up, see if we can figure out what's going on. And there we go. Now we can start taking it apart and have a look a little closer at the inside. Okay, so here's the lightning connector. This is where the charge cable plugs in. There's a bunch of little components back here that we can't see because it's filled with this epoxy that's basically impossible to remove without damaging anything else. If you try to remove it, you can damage these components or tear the cable itself because they're mounted on. So we're not going to do that. We're looking, and I don't see anything obvious that's burned here. Not that we can really see that well. These guys over here all look fine. Don't see any problems there. So then if we trace these traces over here, they go all the way over here onto the board, and then they connect right over here with this connector that I've already removed. I don't see any burn spots on the connector on the cable side or the logic board side. And if we move this adhesive foam pad, you can see a few more components down here that, I mean, you can't really tell very easily whether there's anything going on with them. It's got kind of this also epoxy on it, so it makes them look brown, but they're not actually blown. It doesn't look like. Now, unfortunately, like I said, I don't have another one of these charge ports and flex cables to replace this with, but I feel like it's probably unlikely that there's a problem on this part. I think there's probably something going on the board, and that's also much more in-depth and difficult repair. So unfortunately, we're not going to be able to fix this iPhone today, but I think we have a better chance at fixing the next device coming up, and that is the Nintendo Switch Lite.
All right, here we go. Switch Lite. We got. Oh, that was the loudest snap. Okay.
First thing I noticed is I don't know if there's a faulty screen here, or maybe we don't see a screen protector on here. That could be a problem. But let's plug this in and see what happens. 1520 volts, 0.3 amps. Okay. That's not the worst thing. Definitely did nothing when we try to power it on. But it is taking a charge. Okay, I think the only answer here is to take the back cover off of this thing, have a look at the board. Let's start by checking the voltage on the battery. We have 3 volts, so that is a very good charged battery, so that's part of the problem. The first thing I'm going to do is get this battery charged up. We're going to go from there. Now while everything is charging, I'm going to get out a thermal camera to take a look. We got 143 degrees right there on the board, and right about here is where the heat was coming from, because it was right here and right here, kind of around this connector. And if we flip the board over, that's right where this power management chip is. I'm going to plug it in and let's see if we can pinpoint it any further. It is possible that one of the capacitors around here is shorted, but I feel like it's probably the chip itself. So looking at this, when I have it on the chip itself, we have about 100 degrees. But then when I go up from the chip slightly, we have 144 degrees. And here is that chip under a microscope. Let's take a look at some of these capacitors. It seems like over in this area is where the problem was. So we go here. Yep, we got a short there. Not there. So we got short on this one, short on this one, a short on this one. So that's, I don't know, that chip definitely could be faulty, but also there could be a bunch of other stuff shorted. Let's go take a look at the M92 chip. That's what sort of controls charging. Short so far. Okay, that's shorted, and that's shorted. Now, I'm not totally sure. This one, maybe that's normal to be shorted. I don't think it's normal for this one to be shorted, so it kind of makes me question this chip. But the other thing we have is, look at this little guy. This guy is posted, and there is no continuity here. This should be, there's basically little coils inside here. And so this should be basically variable resistance from this point to this point. So that is definitely a problem. That looks like maybe it acts as a fuse, but clearly it didn't do a good enough job in this case. So I think the first thing we'll do is remove the M92 chip and then see how many shorts we have left. And with that chip removed, let's see if our short is gone. It is not. Okay, so the other thing with this chip over here is that this capacitor right here, I checked with another board, and it actually is shorted too, so this just may have low impedance. This capacitor, however, is not shorted, so that is definitely worrying. I think what I want to do next is remove this capacitor, and then just see how this chip responds and whether this hotspot is still here. So I'm going to do that next. I will replace the M92 chip and just put it back on where it was. And then also I need to install another one of these little guys right here, this little so I'll do that as well. and the M92 chip is reinstalled. I went to replace this and I totally blew it because my hot air blew it all the way off the board and somewhere into my workbench, and it's so small, I have no idea where it went. So we'll worry about that later. And we do have this capacitor removed. So let's see if this board still gets really hot. So when I plug in the board, let's see what happens. Oh, that immediately lights up. Yep, it gets hot real fast. Now, as I'm looking at this, where it's a hot spot, which is right around here, and looking at this capacitor, it looks like maybe there's a crack in it. I mean, I can't tell for sure, but let's remove this and see what happens. And let's test this without the capacitor. Still shorted. That's a bummer. So let's try with this coil and see if that does it. Now we'll check and see if it still gets warm with that coil removed. And I think I misspoke in the previous scene where I was removing the coil. Coils are going to be shorted from one end to the other just because it's just a coil of wires. There's going to be very little resistance there. But with that removed, that disconnects this chip from this circuit right here. So let's see if it still gets hot with it removed. And yes, it does. Still got a hot spot there. Okay, so let's just remove some more stuff. And with two more components removed, we still have a hot spot. We got 150 degrees here and 120 is all around it. So there's still something going on here. I'm not sure what component is causing this hot spot because we've taken off all four of the little components that are the closest to this. So maybe there's a problem on the other side of the board. I don't think so, but yeah, it's just more generalized heat on the other side, and we only get 120s on the other side of the board. So I feel like it has to be on this side, and it has to be one of these components right up here. So I guess we'll just keep taking stuff off until we get this thing going. So let's try something else here. Instead of looking at the heat, since it's really hard to pinpoint, I have a cotton swab soaked with isopropyl alcohol. I'm going to put on this whole area. It's pretty clear. The hottest, the fastest. That chip just immediately got this alcohol right up. This area over here definitely does, but the chip for sure does it much faster. So I think that heat we're seeing on the thermal cam is being generated by this chip. So I think the next thing we need to do is remove this chip and replace it with a different one. Let's just see what happens. Okay. There we go. So I'm going to kind of line it up about where it needs to be. And even with a known good working chip, we still have that hot spot right on that chip. That tells me that there must be something else going on somewhere else on this board, but unfortunately there's just no way for me to know where it is. So once again, instead of having a circuit protection component somewhere near the input charge port, the manufacturer of this board has not done that, and so that high current and voltage traveled through the board and blew something out somewhere, but there's really no good way for us to pinpoint it other than the things we tried, and unfortunately that just doesn't work. So I'm going to get this switch light put back together. Let's take a look at the PlayStation 5 and see if we can fix that one. I'm pretty sure I already know we can't because I sort of know how the USB ports work on the PS5, but you never know. Let's take a look.
3, 2, 1. No! Oh my God!
Since I already know probably what's going on with the PlayStation 5, I'm just going to put this in front and have a look at it. So right here is the USB ports on the board, and right behind that we have where it mounts to the board, and over here we have a little device that kind of looks similar to the switch light, and then we also have this device right over here. So you would think that that could be a circuit protection device, but if we come through and test, there is continuity through it, like there normally would be. So that's not blown. This little guy right here is also not blown. Check the other one. Same. So then these traces go through the board right here. So they go to the other side of the board, which goes to right here. And if we follow them back, they go right into the APU. So instead of designing these boards with some very cheap circuit protection devices that actually work, they've decided to exclude them and make it so a power surge, whether it's from a lightning storm or a USB kill device or something else, that power surge can cause the entire board to burn out, and your $500-ish device is now useless. So unfortunately, I was only able to really fix one of these 8 items that were killed by the USB kill device. Now there are more skilled technicians that probably could have fixed a couple of these, but ultimately I think this video shows how manufacturers are kind of skimping out on circuit protection for their devices. The other thing that we learned today is that the USB kill device is very dangerous and not something to be messed around with, as it can kill devices very quickly and easily without really being able to tell what actually killed them. Thanks again to Austin Evans for sending these devices over. I have huge respect for Austin and his team for what he's doing over on his channel. If you want to see the video where they killed all of these devices using the USB kill device, I'll put a link for that video up on the screen now so you can go hang out over there and see how it works. Thanks again for watching today, and I hope you have a good one. I paid over $1,000 for these 4 broken handhelds. Well, let's see if I can fix them and make some money. So I actually got a good enough deal on these that I probably could sell them for parts and still make money. These go for about $300 on eBay just for parts. So I have about $1,200 in parts, plus this one has the Turbo Vision, which is worth something too. Now, if I can fix each one of these, I could get around $400 to $500 for each one. I haven't tested any of these yet, so let's do that now and see what's wrong with them. So handheld number 1 is missing the battery cover. We've got some discoloration, possible corrosion down here in the battery compartment. Let's get some batteries in and see what it does. These things are battery eaters. Just double A's. And I've heard they lasted for about 3 hours. All right, we got power and nothing. Not even close. Yep, just nothing. Okay, let's get this thing apart. See what's going on the inside. There's something connected to the side. Ooh, the bulk. Oh, we got all sorts of stuff going on in here. And definitely some corrosion down in there. Okay. Oh, here's a major problem. The battery cable is totally disconnected right there. Oh, that'd be amazing if that's all that was wrong with this one. If you want to take this out and inspect the other side of this board right here. So we want to look at these capacitors. I don't think any of them bulging or leaking as far as I can tell so far. I think that one, then we got the major problem here. Is that a capacitor issue or from the battery issue? So let's have to remove this. I think. Here to where we are back here. Okay, we seem to be good on this one. Let's check this one right here. Good there. Good there. That one's also good. And one more. This one here to here. Okay. So all of those vias are actually good. So all you have to do is worry about getting that capacitor mounted on there. Now before we get to replacing this capacitor, I wanted to show the damage these things do when they leak. Here you can just see the underside is just totally corroded from all that leaking. So that's the problem with these capacitors. Leak. We've got a new one, so let's get it replaced. So the first thing we need to do is plug these pads and put some flux on them, and then see if they'll take any solder. I think they probably will, but let's find out. Alright, so I have my large iron, so I can get plenty of heat on these ones. Give this a bit of a scrubbing with the Q-tip. Oh, look at all that it's getting off. Then they come in with more solder. Yep, good there. Alright, that's pretty good. Okay, now, coming on this side, heat that up. Okay, that is looking good. Now, there is this via. I'm going to bring the wire through the via, and, oh, the via's right down there. Wasn't expecting that to cover that up. That's the problem. I need to take this thing back off. All that work I just did. Okay. That's the via. Let's run the wire first and then we'll connect that capacitor. So the wire is going to go down through. We're going to bring this over. Like that. Now we should be able to get our capacitor installed. So, one lead right there. Good. The other one right over here. Good. Okay, that is connected nicely. Now we need to connect our wire. Okay, there we go. Now I just need to connect the other side and we'll be done. So this actually connects to this capacitor right here. So that's what we're going to have to connect to. Okay. So that part of the job is done. And now we have a couple more problems. First one is this capacitor. It's got some black goo leaking out, so we need to fix that problem. Then I noticed this capacitor has a problem. This capacitor might have a problem. And one of these, this capacitor also might have a problem. So I'm actually just going to get those replaced. And I have 2 complete kits, but I have 4 of these Turbo Expresses. So while I want to just replace all the capacitors in all of them, I don't have all the parts for it. So I'm just going to replace the ones that are visibly leaking, and we'll see if that's enough to fix it. So let's start out with this capacitor that's leaking the black goo. We need to suck up the solder from these 2 joints, and then we can just push the legs through. There we go. I'll clean this all up. Make sure any corrosion is cleaned off of the board here. So this gets folded down like that. There we go. Now some more flux. And some more solder. One for that joint, some for that joint. And there we go. I got that one replaced. That is looking great. All right. So let's get these ones done next. So those ones are definitely the worst. I don't see any others that look like they've been leaking. These ones all look fine. And since I only have a limited number of capacitors, I think it's time to put this thing back together enough to test. Oh, but we got to fix those battery wires. So let's do that next. Okay, so this wire is fully corroded. That is crazy. This one also doesn't look amazing, but it's still attached. Also, even down in this connector, it looks like it's kind of green. So we need to get some vinegar and get down in there. Let's do that next, and then we can also put it on these contacts too and get that cleaned up. Okay, I got some vinegar on this toothbrush right here. Hopefully the connector is good and the battery and the connections, the cable connection in here is good. I think it'll be good, but it's hard to know for sure. Okay, now the end of this wire is definitely no good. There we go. And now with that wire all fixed, we got to clean up all these battery contacts. So I'm going to get that vinegar back out and just brush it all around and get all of that cleaned out. Okay, so now we need to make sure that this wire is good from here to the connector. So we'll back probe the connector like this and touch it here. Okay, so I think, I don't know if my probe got back to the connector far enough. Yep, there we go, that one, everything's good. So now we know that that's good. Now we can get this thing back together and see if all that work we did was worth it. Okay, all back together, game's in. Let's see if it powers on. Here we go. Oh, nothing. Wait. No, the screen does get a little brighter. Can't really shoot. Can't really. Oh, there we go. So the screen definitely gets a little brighter, but it doesn't do anything at all. All right, gotta get it back apart. See if we can figure out what's going on. So I have it back apart. One thing I wanted to check is this controller board here. So I have the screws out. Let's have a look. Oh wow, that capacitor leaked all over this board. I mean, all over, all the way down here. Like, all through here, all through here. Holy cow. Oh my goodness. That is crazy. So this entire board, from all the way from here where the capacitor is, all the way up here. This is not great. I feel like when we have this level of corrosion, there's probably, oh yeah, these carbon pads are just disintegrated. Look at that. Okay. So I think that kind of tells us what we're going to end up doing with this one. I think I can replace this board, and that may be an option. I think for now, though, we're going to use this one for parts to see if we can fix the other ones with these boards. Although we know this board isn't working, this board is also not working. So this one might be just unfixable. I'm not sure. But I'm going to set this one aside for now. This has gotten a lot more intense. If I do decide to fix this one, I am going to need to get another one of these boards because I think this one is just not going to be fixable. All right, let's move on to number 2. And with all the batteries in, turn it over and see what happens when we turn it on. Oh, we get the screen sort of comes on. Well, that's actually decently bright. Let's see. Brightness control sort of works. Yeah, brightness control works. Definitely have an audio issue, just get kind of a whining noise. Let's see what happens when we try gaming it. And with the game installed, let's see what happens. And we get the exact same thing. All right, let's open this one up and see what it's like on the inside. As a side note, I don't actually know if any of those games work, so hopefully we're not just testing bad games. But given the fact that there's just nothing displayed on the screen no matter what, I think it's probably not a game card issue. I think it's probably something going on the inside of this thing. So far, there is no battery corrosion, which is nice. I feel like it's probably a capacitor issue. And if this one's not too damaged, I may just need to replace all of the capacitors. I just need to buy a couple more capacitor kits. so I can just replace all of them, and any of these will look fixable, which is hopefully all of them except for that first one. But we'll find out here in a second. All right, let's see what the inside looks like on this one. Oh, we got some sort of mod going on here. I don't even know what all this is. That's a lot of wires though. And this wire is just not connected to anything. Okay. But did they replace the capacitors before they did the mod? I think we need to take this apart further and find out. That's just so many wires. I'm not sure what mod that is going to be for. And we have new capacitors. That is some ugly soldering. But they are new capacitors. This one looks like, oh no, I guess it's connected. Although they didn't replace this, I think that's the original one. Same with these two. Why would they not replace those? I don't know. So all those wires are connected down here to the game slot board. So let's get this thing just all the way taken apart here. Alright. So we've got, yeah, these are all connected to different pins on the game slot. Wow, so this pin on the game slot isn't even connected to anything down here. It's just totally been eaten away by corrosion, but they connected it here. So this board says region switch. So this is some sort of region free mod, I'm guessing. All right, so I'm gonna figure out a couple things. Number one, where this wire goes, and number two, why this thing isn't booting anything up onto the screen. I feel like that has to do with these capacitors that weren't replaced. I'm not sure why you would do all that work to replace all of them except for some, although I guess I just sort of did that, so maybe they didn't have enough, I don't know. So I'm thinking we need to replace this one, and this one, and then we might need to remove this shield and replace some under there as well. So here we are under the microscope because that one loose wire needs to be soldered right to this point right here. So I am going to do that, and then I think I'll test it again and just see how it looks, if anything works after that. I feel like some of these capacitors probably need to be replaced, but we'll just give it a try first. Now we can take our wire and solder right there. Come on. There we go. A nice strong joint. Now with that done, we can try and power it up and see what happens. All right, and back together enough to test. Let's see what happens. And exactly the same thing. Okay, so I think we got some capacitors to replace in here. I want to look at the other two and see if we just need a whole bunch of new capacitors. Because if we do, I need to get those ordered so we can just get those all replaced. I was hoping there would be other repairs than just capacitors on these, but so far, but let's take a look at number 3 and number 4. So for number 3, we get a very dim display when we press the power button. Let's check number 4. Actually, before we check number 4, let's have a look at the inside of this one. We're missing 2 screws right here. That's not great news. Hopefully this one's not too messed up on the inside. And we have capacitors not replaced. And there's definitely some leakage. This one definitely needs capacitors. The rest of it, though, looks to be actually in decent condition. I don't see any major leakage on the capacitors, at least not so much that it's corroding the board. So that's good news. So that's that one. Let's have a look at number 4. All right, number 4. Got a little bit of a screen. Hard to see on camera. It does show up. No volume, and the brightness doesn't do anything though. All right. So probably the same thing here, but get these screws out and see what we need on the inside. And that one's leaking. Actually, the rest of them don't look too bad. Okay, that's impressive. So given that this one is probably in the nicest condition, I'm gonna work on this one first. See if we can get this one working, and then we'll move on to the others. Meanwhile, I think I need to get some more capacitor kits ordered. So I think what I'll do on this one is just replace all the capacitors using the one complete kit that I have. But before I do that, I want to actually just replace this one capacitor right here. From what I've read online, this capacitor affects the screen, and some people say just replacing this one will get it working. So let's try it and find out if it actually does. Okay, that side's lifted. Okay. And there we go. Now I just have to install the new one. One side. Okay. And easy enough, that one's done. All right, all together. Will it turn on and the screen work? Whoa! That does work. Look at that. That is amazing. I can't believe that just happened. Sound definitely still does not work. It really was just that one capacitor. That is crazy. Okay, well, we still got more capacitors to replace. I think once we replace the capacitors for the sound, that the sound will work. But so far, this is great news. Now I'm just going to get it back apart and we'll replace all the rest of the capacitors. So what I need to do first is remove this shield so we can get to the capacitors under the shield. So I'm just going to be sucking the solder up from this point, this point, this point, and this point I think is under this shield. So I don't know, I might just cut that one or see if I can get under it. But that's what I'm going to do now and see if we can get the shield off. Come on. There we go. Got him. And now with all of those capacitors replaced, that was a lot of work, but I think it's going to be worth it. Let's get this thing back together and make sure it still works and see if it has sound. Number 4 is all back together. Let's see if it turns on. It does. Do we get sound? Oh, yeah, we do. Great sound. Buttons seem to work. And we are off. If I can figure out how to make it go. There we go. Look at that. And let's see if this is an open world. It is definitely not an open world. Okay, so number 4 is all fixed. So let's move on to another one and see if we can fix another one. I actually want to move back to number 1 and see if replacing just that one capacitor will get the screen working on that one too. And here we go. I'm going to throw some flux on here. Get the whole one removed. I have this thing partially in the board still, but I think we can do it even still. Okay, old one is out. Okay, there we go. Now, let's get this one turned on and see if that's enough to fix this one too. So put the top half of number 3 on the motherboard number 1, just so we can test it since number 1 is pretty messed up. All right, let's see what happens. Oh, we just get no power at all. Okay, well, I was hoping that would fix number 1, but clearly it does not. Okay, number 1 definitely has more issues, and we will leave it as a part handheld. All right, let's move on to the real number 3. So I ordered more capacitor kits, so I want to replace this capacitor on number 3 and see if that's enough to get the screen working. After that, I will replace all these other capacitors because you can see that they are bulging a little bit. So let's get that done and just see if that gets the screen working. If soldering is something you're interested in learning and just have no clue how to do it or where to get started, I've actually created some soldering courses that are great for people who have little to no experience. In fact, my first course is absolutely free, and then if you want to learn more, I do have several other paid courses. If you're interested in learning more about that, go to GameConsoleRepairSchool.com. Okay, and here we go. Let's see what it looks like when we turn it on. We have a brighter screen. Yes, yes we do. Still no sound, but that one single capacitor fixed that screen. That's amazing. There we go. We got a little brighter there. Okay. So now I'm going to get it taken back apart and replace all the rest of the capacitors, and then we'll come back and see if everything else works. So we've got a trace that's been torn off the board here, and this one looks like it's just totally been eaten away. So let's get on the microscope so we can check that out closer. So unfortunately, this pad is torn, and this pad is also torn, which means we don't have a great mounting system for that capacitor. So I think what I'm going to do is use either some CA glue or epoxy and epoxy that down. And then we need to make sure the negative, the ground pin is connected here, and the positive pin is connected to this trace right here. So I'm just going to use a little grinding pen to grind off some of the solder mask down here. And then the same thing over here. We're going to try and do it carefully without destroying this piece, but I might destroy it. Alright, and that looks pretty good. So what I'm going to do next is attach the capacitor to these circuit traces, and then we will attach the capacitor to the board. If I attach the capacitor to the board first, I'm not sure if I'm going to have enough access to these pins to get them soldered onto the capacitor correctly. So let's add a little flux. Now come in with the solder. Now we will try to attach our capacitor somehow. This is going to be pretty difficult. Yeah, I'm going to need to extend this one out here a little bit. So I'm going to add a wire to that, and then we'll attach this side here and this side over there. The wire is going to be nice and long, because if it's shorter, then it can melt the solder when I'm trying to solder the other end of it, whereas if it's longer, it's more likely to not do that. Okay, there we go. Let's get that soldered on a little bit better. Okay, now, the main thing is trying to get this thing soldered on to that ground pin over there in a way that it will stay where we need it to stay. Could be difficult. Right about there. Didn't get it. Okay. I think we need to add more solder over there. It's just not close enough to stay soldered down. Or not close enough to connect. And so close. Got it. Okay, there's that. Now, we can solder this side down. Onto this wire. Okay, definitely not ideal, and now we have to fit, I don't know if we're going to be able to fit the other one over here. So this one needs to go on here. Yeah, we're going to have to move it a little bit. Okay. Hopefully we can make this work without causing any problems. So, do this more. Okay, how close are we now? Pretty close. In fact, I think close enough, maybe. That felt good. Get in on this side. Okay, I think we're good there. Definitely good there. Oh, wow. That was difficult, but I think we have it. Need to clean this up and then get some CA glue on it. We'll cut that wire off there. Hopefully we can clean that up enough to even get CA glue on it. Yeah, that's good. That might be enough to keep it, but I want to stabilize that a bit. So we'll do that in a little bit. I want to get the rest of these capacitors replaced. But yeah, I'll clean this up after I get this big capacitor on there. We'll clean that up and get it glued down so that can dry while we're working with the rest of it here. Got it? Got it. Okay, the rest of these I'm going to replace off camera. If something exciting happens, I will turn on the camera and film it. So we have every capacitor replaced on this board. We have this little capacitor replaced. Now let's get this thing back together and see if the sound works. And back together, batteries are in, game is in. Let's see what we get when we try to turn it on. Screen, do we get sound? Yes. That's what I'm talking about. And this one is also leaking, which is no surprise. I'm going to get this done off camera. If I find something interesting, I will for sure film it. All right, and we now have all of those capacitors replaced. So, this is good. We're ready to put this thing back together and see if it'll work now. All right, and number 2, we'll all back together. We got a game in it, have the batteries installed. Let's see what happens. We turn it on. The screen lights up, and nothing else happens. No sound, no video, no anything. Okay, well, let's open up and have a look at it on the inside one more time and just see if there's anything going on that we can figure out. So we're back under the microscope. I found this capacitor that's not even connected, and then I found this other capacitor that is very loose. So I'm not sure if these are the cause of the problems we're having, but I'm going to go ahead and get these soldered back in their correct places, and then we can put it back together and test it. I've also noticed there's quite a few capacitors on here that have traces that have been torn up, that the previous person repairing it just soldered to those loose traces. I don't know if those traces are broken somewhere either, so this board is turning into kind of a mess. I think if this doesn't work, I'm going to just call this one unfixable, because there's so many issues between the capacitor problems and then the circuit trace problems, and then we have the problems with the game slot. Some of the game slot pins are just totally eaten away by corrosion, and then we also have this mod that was installed, and I'm assuming it was installed correctly. I checked a bunch of the wires and it seems to be, but I'm not totally sure on that either. All right, and there we go. We have it all fixed up. Let's get it back together and see if it works. We've got the battery in. We've got the game card in. Let's see what happens when we try and turn it on. Come on. Oh, hey, the screen brightness changes. I mean, that's good, I guess. But unfortunately, we've just got nothing. So unfortunately, I'm going to call number 2 not fixable. There's just too many issues on this board, and even if I was able to get it working, there's a good amount of corrosion around the game slot pins, and that could cause problems in the future. So I'm going to use this for parts for future repairs. And that means we're able to fix these 2 out of the 4 we got. Not the best results. I was hoping for better, but 2 out of 4 still isn't too bad, and I love bringing these old handhelds back to life. If you want to see a video where I tried to fix every single color of the Game Boy Play Loud Edition. I'll put a link for that video up on your screen now, so you can come hang out with me over there and see if I was able to fix those. Thanks so much for watching, and I hope you have a good one. Let's see if the controller is turned on. There we go. So when the eBay buyer got it, it wouldn't turn on with the controller, so maybe that's the only reason they decided to return it. Either way, it does turn on with the controller, just has to be paired with it first. Now let's get this thing taken apart. Alright. First plate up. Second plate up. There you go. And it looks like all the pads are there. The mounting pads don't look like they're there. But that looks like it's going to be totally fixable. So I was also just noticing we'll probably just go ahead and replace this whole fan. Yeah, there's the fan. Connector is totally chewed up. I mean, this fan, it probably would work, but I don't like having that exposed wire right there, so we'll get that replaced once we get this thing going back together. So over here is where the power button connector is. So it could be a problem here, it could be a problem on the power button board down here. We'll also look at that in a little bit. So we've got to get these 42 totally necessary screws removed first. We can get this metal plate off. And with all of that removed, everything looks good there. Clamp is installed. Good. Don't see anything crazy going on here. Good. Right. Dry spot. Look at that. Hey, you can see with a little more hair. Here's the thing about I think it's real game console toolkit. This is their Xbox toolkit. It comes in a nice standard pouch with a nice quality top, and this is what it has inside. First, we have a nice brush that you can drill out, keep things nice and clean inside, and like that a grip strap that sends out good quality cleaners, and tiny cleaning cloth, of course, a plugger. I use these all the time. Change that up a little bit, okay? Security key 8, security key 10, and security key 6. A metal plugger. These are super good for prying off
Guys, we're gonna be removing this transmission soon, guys. And if you wanna stick around to see this live transmission coming out for this Pathfinder, stick around. See, it's just kind of starting to spread around now.
So now I'm just going to use this black woven cotton bud. This is what comes in with liquid metal. You buy it. And just start spreading it around. Now we're going to have just to make sure that it's not getting close to leaking everywhere. And we can get through the bucket board. I can't say that there's anything possible here. The round table looks okay, but I think what I'm going to do is replace this, and then we'll test it and see if it works. So I'm going to harvest just the screws from this PlayStation 5 board. Not a this one. I think that was dropped or something like that. This board might be easy, but I'm going to use PlayStation 5. Now we've got a good board, good screws. Stick this cap on this back and frame. And then get to this motherboard. So here we are on the microscope. This is the area board that this connector is going to come off. And look at the connector. It looks like we've got 3 good metal legs. These are the pads that we torn off the board right here. And look at the rest of the connector. In good condition. Yeah, this looks good. So this was on here about like that. So what we need to do is probably move this back just a little bit. That will make it so we have something to attach these 2 legs on. We can get it attached to or connected to these 2 circuit traces right here. And then if you have it moved back just a little bit, we'll be able to connect these mounting pins to this part of the board right here. So next what I'm going to do is use a little grinding pen to grind away solder mat on the board. And then I will use my soldering iron to add solder to that area. And then also I will do the same thing for these 3 circuit traces right here, especially these 2 that torn off or partially torn off. I'll come along and grind off the edges of it, add some solder, and then we'll have something to grind. Now I also do want to say if this is something you're looking to do and you want some written instructions and it goes a little more in detail into how to do this, so you can find that at TechFix.com. And I would say looking at the instruction that if you like constantly adding things onto the repair page to your website. So if you're interested in doing that for repair, we've got lots of
I'm mad. See that? Walk.
So now let me work now. Let me work.
Well, it's $20 an hour. You get hour. You $10 an hour.
What? I want to call the government for you, man. Minimum wage is not $10, buddy.
$10 an hour if you work 4 hours, you get $40.
I'm mad.
Better than Uber.
I'm mad. No, Uber, yeah. Yeah. You want to show me, you want me to show you my last thing?
They live there. Kitchen machine ready to come on. Just have to set the block. It's a good challenge, baby. Ah, what's that for grand challenge?
Wait, George, you call you ready?
Charge me $15.
$15?
Mhm.
1.5?
1.5.
Not mad.
Text him and I read the message, you never reply. I'm meeting my cowboy. Look at meeting last week. But he had good fight this week. Come. Okay. Trying to show you how you do it. Don't come out now. I'm going right there. This jack in the company. Have you got on the jack?
This one?
Mm.
Okay. Only feed out?
Yeah, jack up.
Jack up, man?
Jack up. Go. Go. Take the jack on. Okay. Engine on. Eh?
Really good. So I'm going to put on the mud.
No, you ain't China again, man.
Huh?
You ain't China again? I think all the time I show you now.
Huh?
How you walking?
That's it. I don't think it's that opportunity I have there right now. Shit.
How you cracking?
I don't think it's that opportunity.
I forget a connection for this minute.
I send that for the deal. You're getting mad. Okay.
Is it live or not? The one in China?
Yeah.
How many hear nothing?
One component for you. The thing get you can get the
She like that?
I mean, she never watched that bitch. She doesn't watch that kind of thing. I see it. It's a yellow film. I see her. Oh, the time changed already?
You know,
Huh? Yeah.
forward.
What? It's already 6 o'clock, buddy. No.
Telling Jim.
So, how it's 6 o'clock already? That's going like 55 kilograms. That's slim now. Huh?
Mhm.
Yeah, 55 kilograms. And the girl said she wants to be 45 kilograms. Yo, this girl should go that way, man. Yo, yeah, I want to do that trade, but you have to teach me for sure. Real thing, serious.
Something. Yeah, on the chair.
I kill you trade. I think anything I put in my mind to is what kill somebody. You know the first thing you should teach me? Brakes. How to change brakes. Brakes and stuff. Then after I go from brakes, then I gotta move up to other things.
We teach you now.
Huh?
You work hard. Not even dollar. You work hard, the man work here and give money to buy to wash your clothes. If you go flat, but it's good, but this connection here doesn't forget this connection anyway.
A flat is very
Good.
just pay me and I could organize your place nice and clean, everything in order. And props. I come there on Sunday and I fix up everything for you, make everything nice and clean. What do you say?
That's how I gotta go to work.
Ah,
We're gonna start.
Sunday I come and do for you.
You don't know where I want my
I
shit.
put everything nice and clean for you, everywhere.
I'm looking for this fucking big boy.
You right now you're looking for a pick, you can't find a pick. No, I think I know that thing.
And if you organize it, I can't find it anyway.
But I will show you. I make it map for you and all. And I give you that, show you, give you a map in your hands and say, look.
I don't pick a boy. Alright. Come on. Come on, board. Okay. That's because they've gone underneath. You ain't doing nothing on these gloves?
I mean, I do nothing. You want me to do things for you? You want me to have gloves? You want my bare hands?
Just have to jack the jack.
I don't have jacket.
Okay. Jack up the jack, let me see.
More?
Yes, thank you.
So Chico working here now in Calgary?
Something catches you.
Chico working in Calgary now?
Mm-hmm. So long. Look at me, man.
Yo, look a freaking thing. One thing on that screwdriver you put there.
It's pen. I don't know if the jam here, sir. I mean, how done a volt.
Basically the same radius. Maybe my probe was touching this when I was testing it. I don't think it was, but it is possible. Maybe what I'll do is just go ahead and replace this since we do have replacement port just sitting right here. There's not a lot of history of this problem, so there's not really much to know what might be causing this. So let's get that replaced. And use this and fix it up. And adding flux and putting the chip back on is pretty important because you get everything just right and it'll just kind of float right into place, just like you saw it do. Okay, now I'll just let it cool down and then I think we'll just install it into the system and see if it works. Now I have decided if this doesn't work, I'm going to be done with the diagnosis on this because there's not much else I can do. Hopefully it's going to walk in the power. Next button working.
You put them on into the mount.
After all
Put
that,
the attention there.
Easy. I do want to care about the boy.
Why you don't paint that? Why you don't paint your garage floor so the oil will not stick?
I'll clean it first.
That's a special oil. Special paint you could
I have it out already. 2 minutes. 2 minutes, give me a password.
What?
It look like you have both inside the fucking, inside the wrong hole.